Bonjour à toutes et à tous. Je vois que le nombre de
So good afternoon, everyone.
Nous allons attendre qu'il se stabilise un petit peu avant de commencer ce webinaire.
And before starting, we're going to wait for everyone to get in and get settled in.
Bonjour à toutes et à tous. Je suis Céline Damry du Conservatoire du Littoral.
Good
Merci.
afternoon, everyone. I'm Céline Damry from Conservatoire du Littoral, and thank you for being here. We are going to be talking about light pollution and the impact on biodiversity. So we've already had a first episode, which was some kind of introduction, and we've been talking about the impact on biodiversity on coastal areas, on islands and small islands, and there have been some proposals. This is a crucial subject today, and so we decided to have some sort of, awareness moment. So I'm going to introduce the program of the webinar. I'm going to give you just some logistics for those of you who are not used to webinars. So for participants, you'll be able to ask your questions to our panelists during the Q&A moment. And to ask your questions who are going to be retranscribed, you can write them in the chat box. If you want translation and interpretation, please choose the channel below. And so you're going to be able also to hear our speakers. Everyone is recorded, so it's good for the people who are not speaking to switch camera and mic off, not to interfere. And also this is going to be broadcasted on the YouTube channel of the international delegation. So just to give you a framework, Conservatoire du Littoral is a French public institution whose mission is to acquire parcels of coastline threatened by urbanization or degraded in order to turn them into restored, developed and welcoming sites that respect the natural balance. Today, we own about 200,000 hectares on a network of about of a few thousand sites. This represents about 13% of our coastal area. We go from dunes in Lille to falaises to mangroves, and we are working together with many different associations, and this is why we work with international organizations, and we share globally the savoir-faire and the return of experience of others. And then we have brought about the eco-solution management in order to share good practices. And also we have done different webinars on different subjects, like last year, managing sea turtles, mangrovias, cats on the islands, carbon bleu. We had several series of seminars, and this year we are going to be talking about light pollution and also on the observation of the coastal area. So the first episode, we've done it last week, and it was focused on sort of large definitions of the issue. Today, we're going to get a little bit more into detail and give a diagnosis of light pollution and its impacts on biodiversity. And next week, hopefully we are going to share recommendations and solutions to limit light pollution. In the chat, you can see all the links my colleague has suggested to look at the first webinar, the one that we did last Tuesday. This is our staff for today. So Marie, and she is going to moderate all the questions in the chat box. Angelique, she's back office. And so she's going to be helping us if we have any technical problems, Isabella with translation, and myself, Celine. In terms of program, today we are going to have 3 speakers and 2 sessions of Q&A, and we're going to be able to talk about the presentations. Our speakers today, Lauren, Fernando, and Philippe, and obviously, we're going to get different examples from their regions, their areas, and so I'm going to let them introduce themselves and talk about what are their subjects. Philippe? Thank you, Céline. I am Philippe Devercher. I am a technical manager of Dark Sky Lab. This is a structure that delivers services around light pollutions to institutions and private players. I come from engineering, so I've had a classical training as an engineer, database engineer, and then in 2016 I started dealing with light pollution, and coming from the world of astronomy, I realized that the problem wasn't only the fact that light pollution has an impact on observations, but also on biodiversity. So now I am in charge of softwares in Dark Sky Lab, of developing softwares, and I work also with universities. So this is what I can say about myself. Thank you, Philippe. Thank you for being with us today. So I'm going to give the floor to Fernando now.
Okay, hi everybody. I'm Fernando, obviously, so I'm here representing an association in Portugal. I'm not originally from Portugal. I'm from Mexico. Most of my work has been GIS driven, like as a GIS analyst. Right now, like most of the tasks that I'm working with have to do with the analysis of light pollution across the Micronesia region, and how to actually qualitatively and quantifiably how to measure it in a 2,000 sites. And I think for now, that sums it up.
Merci beaucoup et merci.
Thank you, Fernando. Thank you for being with us today. And then I will now leave the floor to Lauren.
Hi everyone, it's great to be part of this webinar tonight, or at least it's tonight in my time zone. My name is Dr. Lauren Peel. I'm a senior marine scientist at Pendoley Environmental here in Perth, Western Australia. We are a marine science consultancy that specialises in marine turtles, seabird and artificial light monitoring. So I'm looking forward to using my time tonight to talk about our unique combination of work scopes and to highlight why it's important to consider artificial light in a biologically relevant way and how we can align artificial light monitoring with biological monitoring as well to really maximize the impact of our efforts to conserve our night skies and also, manage our artificial light. And I believe I'm kicking off tonight as well, so I'm ready for my slide when we can start.
Tout à fait, c'est à vous et je vous passe votre première slide.
So it's your turn and I give you the first slide.
Awesome, thank you. So last week's webinar kicked off with a discussion about what artificial light is, the characteristics of artificial light that we need to focus on when we're talking about impacts to biodiversity. And I wanted to touch on that a little bit at the start of my talk. So artificial light is any source of light that is not natural in nature, so not coming from the sun, the moon, or the stars. And humans are exceptionally good at putting artificial light into the environment, whether that's lighting up our cityscapes, lighting up our ships and ports for navigation reasons. But it's not only light bulbs that we use to generate artificial light, we also inadvertently generate light through industrial processes. For example, this is that second image across from the left is a ground flare near to a turtle nesting beach. So this proximity to artificial light, while humans typically just enjoy the light, use it the way that they see fit, it's not often that the general public considers what sort of impact that light can be having on the world around them. And that's where a lot of the work that we do at Pendoley comes in, and a lot of the work in the artificial light space has been focused on. So moving on to the more biological aspect of artificial light impacts, it's important to know that not all eyes are made the same. So the way that other animals view the world isn't the same that humans view the world. We have a visual system that is more sensitive to slightly warmer wavelengths of light in that green-yellow region. So that figure to the right of my slide with the curve over the top, that's how we perceive the world. But other animals are sensitive to different wavelengths of light. So for a lot of species, they're more sensitive to blue, cooler wavelengths, and that is the case for our marine turtles shown at the bottom here. That's a flatback turtle. And this is important to recognize because how animals react to artificial light is going to depend on how they perceive it. And if we monitor artificial light using equipment that is designed around the human visual system, we're not necessarily going to have the right information to act appropriately. So with that in mind, I'd like to use an example of how we monitor hatchling turtle orientation on beaches and align that with artificial light monitoring work that we do too. So measuring biologically relevant artificial light is not an easy task. We have tackled that challenge by designing our own camera systems called Sky 42 cameras. You can see one on the left here. So our Sky 42 cameras are a DSLR camera housed within a rugged casing and capped with a fisheye lens. So this rugged structure with an automatic lid means that we can go and deploy our cameras out on turtle nesting beaches and capture images of the night sky frequently throughout the night to literally capture the full night sky. So these circular images, the one on the left is a raw photograph captured by one of our Sky 42 cameras. And just to give you some orientation, the red N represents north, and the perimeter of that circle is the entire horizon. So if you imagine yourself looking straight up, that image captures all of the sky above you, including the Milky Way through the center. Now, this is where our astrophysics team comes in at Pendoley. They take this raw photograph and generate isophotes, which are effectively heat maps of light, using known star brightnesses from the sky. And this is important because those points of reference are also the brightnesses that other animals would see in their environment. So doing this provides us with a way to have a standardized metric of light that we can compare across sites and apply to different situations. And just as a reference for that rightmost image, this is our isotope for that same raw photograph. And the important thing to take away from the sky brightness values is that it's an inverse log scale. So our lower values actually represent much brighter skies than our larger ones, which you can see from that color bar across the top. So that's how we're capturing our artificial light data. Next slide, please. Great. So this is where we start our biological monitoring. So for our marine turtle hatchlings, these are little flatback hatchlings in the photo on the left coming out of their nest. You can have 50 to 150 hatchlings leaving a nest over 1 to a couple of nights. And as those hatchlings make their way down to the water, using the brightness of the ocean from the reflections of the stars and the darkness of the dunescape behind them, each individual track forms a hatchling nest fan, which you can see in that central image, with the outer arms of the fan shown in yellow and the most direct path to the ocean shown in blue. Next click, please. Great, thank you. So what our biological teams do is they monitor these hatchling fans and record the angles of those 3 lines. This is because ideally you'd see your hatchlings moving down the beach in a direction that allows them to get to the water effectively and efficiently. But when you start introducing artificial light into these scenarios, you can have events of misorientation and disorientation. And this is because our hatchlings, like their adult counterparts, are very sensitive to blue wavelengths of light, which are increasingly abundant in artificial light bulbs, particularly in LEDs. So if you have a bright light on land, you might see misorientation, which is that center example, where all of your hatchlings are going in one direction, but not towards the water. Or you can have disorientation, say where there are a lot of lights on the horizon and the hatchlings don't know which way to go. So they end up with a very wide nest fan, spending a lot more time on the beach trying to find the water. Now, this is really important to consider from a biological perspective because the more time these hatchlings are on the beach, the more energy they're using, and it's already in limited supply. They're more exposed to predators as a result for that. In Australia, we have everything from big lizards to possums to ghost crabs on the beach that can grab these hatchlings while they're on their way to the beach or to the ocean, sorry. And then when they get into the water, an artifact of that energy loss is that they then have to overcome the next challenges of getting through the wave fronts and avoiding predators with less energy. And for animals that have a very low likelihood of making it successfully to being an adult, as it is, when we start impacting their populations like this, you can see significant impacts in the long run. So understanding how hatchlings are orientating on the beach relative to light is an important thing to know. Next slide, please.
Yes, just an issue from Isabella. Lorraine, if you could talk a little slower, it would be great. Sorry.
No worries. Oh, that's okay.
Thanks a lot.
Yeah, that's fine. Thank you for letting me know. So what we have now is our hatchling fans on the left. So we can consider the spread of that fan, so the angle between A and B. We can also consider the offset angle, so how much that fan is deviating from the most direct path to the ocean, which is that blue one again from the last slide. And we can align those angles with what we've seen in our heat maps of light or our isophotes. So in this central figure, the bottom image is the same isophote that was in my previous slide, but rather than the circle representing the horizon, the bottom of that image is now the horizon. So we're going from north on the leftmost side, all the way through to east, south, west, and north again along the x-axis. We've also got our sky brightness on the y-axis, where lower values are brighter skies. And then underneath that, along the same angles, we have our spread and offset values from our hatchling fans. So looking at where our hatchlings are orienting relative to where the brightest part of the sky is, we can start to figure out if the lighting that's present in the environment is impacting hatchling orientation. In this case, it's not, because the peak in the spread and offset is not aligned with the central peak in sky brightness in this case. But if it was, we would be triggered to start looking at ways to mitigate that impact, whether it's removing the light completely, finding a different color or type of lighting, putting a timer on it. And it's a really, I guess, quantitative way of working out if light is having an effect on our hatchlings at our nesting beaches. Next slide. And just to round out about the, I guess, the value in aligning our artificial light monitoring with biological data, we've already seen management outcomes in the form of the National Light Pollution Guidelines for Wildlife, which considers impacts to specific taxa from light. Stay tuned for next week's webinar for some more information about that. We broaden our knowledge on how artificial light influences different species, which is the case for marine turtles. And with any sort of technology, we're improving the way that we can actually monitor and model artificial light. So another element of our work at Pendoley, looking at that rightmost image now, we can look at the current night sky, model what a new development might look like based on the lights they want to use, and then combine those two isophotes effectively together to consider what a new development might look like and identify potential issues before they exist in the environment. So collectively, a lot of value in considering our biological data alongside our artificial light data. And I think it's a really great way of maximizing the outcomes of everyone's efforts to better manage artificial light and conserve our dark skies. Thanks.
Merci beaucoup, Lorraine. Thanks a lot.
Thank you, Lauren. Thank you. So before giving the floor to Philippe, I have a question in terms of the measurement tool. Is it something that we, is it reachable in terms of equipment?
For the light monitoring or the biological hatchling monitoring?
For the light monitoring.
So we have our Sky 42 cameras at Pendoley. If people want to reach out about those, I'm more than happy to chat about that. And that's how we've been approaching this. I'm not sure if other people have different strategies. I believe Philippe might be touching on that in the next presentation, but that's the technology we've been using.
Okay. Merci à vous.
Thank you. So now I'm going to give the floor to Philippe, who is going to talk about his experience at Dark Sky Lab and the project that he has been involved in. So the floor is yours, Philippe. Yes, thank you, Selina. So I will speak today about modeling of light pollution. In terms of modeling, we talk about different data sources, typically satellite radiance, high resolution and low resolution satellite radiance data, and also which data are accessible freely. We can also start from orthophotography, therefore nocturnal photos that are done from the skies. We can also utilize geolocated light sources. In France, we have a lot of best practices, and we have a lot of database for geolocalized light sources. And then we can also use land usage data or population data. And normally this is very good for having a good estimate of the light sources. So next, please. Right, so we're going to start from this database. We start from a model and we create an estimate of sky brightness near zenith, which is something a little bit more standardized in conditions that are very clear, of a clearer sky. I really insist on the fact that we are talking about average clear sky, but we can also model light pollution with a covered up sky, with a sky with clouds. Because it's very important to keep in mind that often light pollution is more important during cloudy skies than during clear skies, because the clouds reflect the light. So we use this type of tools. The chart that you can see on the slide shows the types of pollution. Lorraine has already introduced this beforehand. And so with a lower value, the sky is very luminous. and with a higher value, the sky is dark. You can see also the different types of light pollutions, and you can see that some areas are more impacted than others. So this modeling can be done in different scales, and here you can see that the modeling is done on the western extremity of Bretagne in the Brest area, the area of the city of Brest. And so you can see also here that the sky is darker on the eastern side in the natural regional park, and you can see also the different intensities. We continue, thank you. So you can see a small zoom on the island of Ouessant, and is just northwestern, sorry, of an area called Molène, of another island called Molène. You can see these are data that were gathered in clear sky conditions near the main infrastructures on the island of Ouessant. So the port, Stif port, is the main source of light pollution. And you can see that the intensity is quite elevated because it goes all the way to the suburban skies near the port. And this is simply caused by 11 LED projectors, very powerful, that you can see on the photo. More western bound, you can see the small village of Lampol, which is not so important, and then the lighthouse of Créac, which is the most important one on the island and one of the most powerful lighthouses in Europe. On the right-hand side, you can see again the scale of light pollution that is currently used on many maps. And then you can then see what are the typical environments associated to the different types of light pollution. So very dark skies, all those dark violet color, then rural is green, suburban areas are yellow and green, and then urban is red. And so the very dark ones are the one outside of the rural sites. Next. So this was the modeling. Now, in terms of measuring light pollution, in my company, we use our own tool to measure light pollution, some photometers. You can see one here on the right-hand side, and here every minute at night it takes a measurement of the brightness of the sky. So typically we obtain this type of curve, and you can see also NSB, night sky brightness. And on the bottom of the chart, you can see the more the sky is dark at the zenith, and on the other side, the different times of the day. So you have the sunset, and then you have sunrise on the right-hand side, and then you have moonrise with a moon that was rising around midnight. So you can see that even the moon has an impact on the luminosity of the sky. Normally, we don't consider measurements that are taken during a moonrise. So it's quite easy to interpret these curves. Can you see that the kind of smooth portions are normally signifying that you have a clear sky with no clouds, and where you can see a little bit more chaos with peaks and sudden changes? Well, these concern skies with clouds, cloudy skies. And you can see that that night we had some clear skies, some clouds, which is typical of Bretagne, if you have been there. And then you can see that the peaks are essentially associated to the light that comes from the port infrastructures of the stiff port, those very powerful lights, and with clouds, the impact is even higher on biodiversity. Because the clouds do reflect more light, the light coming from those powerful sources. So this in terms of measurements. Now, another way of measuring light pollution is using, just like Lauren was showing in her presentation, a calibrated device. We call this a sky quality camera that will measure the luminance of the celestial sphere in one shot. Next, can you see here? There is a picture of all the hemisphere. This is not a spherical view like Lauren's presentation, but it is a reprojection where the zenith is on the top line, vertical line, and you have a panoramic view of the north going from the east, the south, the west, and going back to the north. And so we are coding the brilliance of the sky. And here, this allows us to associate the different halos of light pollution. Here we had fun finding the 5 lighthouses of this island. And the main halos are coming from the Brest urban areas, which is about 40 kilometers wide. And of course, the light of the stiff port on the right-hand side and the village of Lampol, which is kind of mixed with the light coming from the lighthouse of Créache. Now, to finish my presentation, why modeling and measurements are important? Because we are trying to estimate the impact of light pollution on biodiversity. In fact, a large part of all species are impacted by light pollution. About 30% of all vertebrates and less than 60% of all invertebrates are nocturnal. And even for day vertebrates, they are very active during sunset and sunrise. Of course, light pollution harms human health. We know that. It does alterate the circadian rhythm when we are exposed to intrusive lights during the night. Another important thing is that the long-term impacts of light pollution is not yet completely understood, completely known. So it's a very new field. There's a lot to do. So in these terms, it's very important to have a diagnostic to understand how to progress and how to find solutions that can improve public and private lighting. Because even private lighting is more and more present in all of the developed countries. For me, it's everything. Thank you. Thank you, Philippe. It was very, very clear. Now, maybe a few questions. We could see the halos, and so the question is, I'm sorry, but her voice is coming and going. So the question was about the halos and the generation of lights. So more or less we are studying, of course, marine environments and coastal areas, but I would say that there are not many areas in the world that are preserved from light pollution. Maybe the deserts, where the skies are very clear. But as you go closer to coasts, the human presence is there, and it is always associated to light pollution. So the coastal areas are particularly exposed to light pollution, and this is very problematic because we know that shallow waters are important for many species, and so that is a huge impact of light pollution. So it's very important to continue impact studies on coastal areas. Thank you, thank you. I can see some questions in the question box. I will leave Marie to read those questions. Yes, there's many questions. The first is about the participative method of measuring light pollution. Are there programs, participative programs already going on that can, for example, involve citizens? And if there are they efficient? I don't know who would like to answer. Well, I can answer. I can speak for France, of course. There have been some attempts of some kind of a participative action to ask for help from volunteers to measure light pollution. It's quite difficult, though. It's a difficult area. It didn't really go very far. There was the idea of asking people to, for example, detect luminous points. But it's very difficult, you know, there's safety problems, because if you're asking people to go out at night on roads, you know, it's a little bit difficult. So this creates problems in terms of safety of the volunteers as well. There are indeed some kind of democratized project, but you know, we're still working on it. It's still work in progress. At Skylab, we're working, for example, with the French Office for Biodiversity, and we hope in the near future to have solutions to actually stimulate participative methods for measuring light pollution. But today, as far as I know, I don't think there's a lot of this going on. Lauren, would you like to complete the answer?
Yeah, so to echo Philippe's words, I think the challenge is about the consistency of capturing that sort of data at this stage. As we saw, the presence of the moon can impact artificial light monitoring work, and even clouds in the sky can really change the data that you get. So from a citizen perspective, I think we're still at quite an early stage of understanding how much we can simplify the data capture process. But there are obviously, I guess, more activity-related initiatives like Earth Hour, where everyone's encouraged to switch their lights off for an hour, and raising awareness in that way, I think is quite valuable, because it is an under-talked about pollution in some respects. And what I think is neat thing about light pollution is it's not persistent in the environment. If you switch the light off, it's gone. And I think that's really powerful when it comes to community engagement in understanding how quickly a small change, whether it be switching a light off at nighttime or changing the color of light globes in your house, can make a local impact. But yeah, still a tricky one for citizen scientists to get involved with, I think.
Merci beaucoup pour vos réponses à tous les deux.
Thank you for your answer. Of course, this will also be part of the next episode, so about solutions to light pollution. Now, to stay on today's topic, which is measurement, there is another question, and they would like to know what are the elements to take into account in measuring light pollution. I will answer. The Anglo-Saxons say name it. They have an expression for it. You name it. That means there's so many different ways to measure light pollution. There are so many elements. You have, for example, to pay attention to where you position your instrument. For example, doesn't need to be exposed directly to near sources. Of course, meteorological conditions are primordial. Different qualities, such as different types of sky, different types of cloudy sky that produce different reactions, and also the measurement of the brightness of the sky. For example, the Milky Way is a classic distortion of these observations, the presence of the Milky Way, or photoluminescence of the sky that can really play a role in changing the data. So there are also non-artificial sources that can have an impact on these measurements. So it's very important. There are distortions even in these types of measurements. Thank you, Philippe, for your answer. Lauren, would you like to say something? Would you like to add something?
Yeah, just quickly, I guess from a practical standpoint, other considerations include security. So if you're going to leave a camera out all night, you want to make sure it doesn't get stolen. And also battery power in any equipment you put out. If you are monitoring all night, making sure you've got the battery to collect the data that you need, which sound really simple in practice, but sometimes actually executing that is the hardest part. And also for us, things like turtles knocking your cameras over in the middle of the night, you want to make sure that you've got gear to deal with anything the environment can throw at you from at least a remote field setting, which is what we deal with quite a lot. So yeah, hopefully that helps from the practicality side of things.
Merci beaucoup pour vos réponses.
Thank you so much for your answer. Now we're going to get to the last presentation, and then we will continue with Q&As after. So thanks to the both of you. So we are going to continue. We're going to save the questions for later, for the last Q&A session. So now I would like to invite Fernando to turn on his screen and talk to us about his experience on the Macaronesian region where he's been working, and the Canary Islands as well.
I don't know. I'm
Fernando?
unable to turn on. Hello.
Si vous avez un
I'm unable to
problème,
turn on the video.
pas de problème. On reste comme ça alors.
It's okay, you can stay like this.
Okay, it's fine. Once again, thank you for letting me participate in this webinar. And without more introduction, as we already did, so we are participating here to present a little bit of the work that we're doing in SPEA, which is a Portuguese Society for the Bird Studies. And we can move on. So about our work on mapping light pollution. So this is encompassed with one of the biggest projects we have over here under the name Nature at Night, where we have specifically two objectives. So which is kind of funny for me here in our past participants, because it's mostly a combination of their two approaches. Right, so from the one side is measuring night sky brightness on Natura 2000 sites, basically like protected areas. And on the other side is mapping inland and marine light pollution, right? So this is in the Macaronesian region, just in case someone give it a little bit of context, right? It's on the Atlantic. And here we are participating in the 3 archipelagos, right? But not all the islands in the archipelagos. For example, in the Azores, the island of Corvo, which is a very tiny island, and also the island of Brazil. Then we have the archipelago of Madeira, where we have Madeira and the deserted islands. And lastly, in the Canary Islands, we have 2 municipalities as partners. One in the island of Tenerife, and another one in the island of the Grand Canary. We can move on. To tackle these two objectives, on one hand, so we are doing something that has been shown previously, which is some photography and using a photometer, right? So we go to the certain sites, specifically inside the Natura 2000 sites. It has to be inside or as close as we can, because some of them end up being like cliffs, right? So it's accessibility is a challenge here. And we use this photometer, but basically it's a photometer which maps like the sky dome. We will see a couple of examples. On the other hand, so for the second objective is the remote sensing part, where we are using publicly available low resolution information and privately acquired high resolution. We can move on. Next slide, if it's okay. Okay, so for the photography and the brightness measurement, right? So there are a couple of things that we are doing here. Regarding the photography, this is what we try to do. We try to get as much of the landscape as we can, in terms of a lot of the qualitative part, right? Like find the hotspots or the sources of brightness, right? For that, we use a panoramic just shooting for cardinals, but as the other examples have shown, we also shoot to the zenith, right? That gives us a very nice characterization of the landscape. At the same time, while we do not shoot constantly, what we do is we take a couple of pictures across the night. First, with the idea of capturing the early night, where we have most of the human activity and therefore most of the artificial public or private light usage. This goes all the way into the night, later night, where we expect least human activity, therefore less use of artificial light. Now, the sky photography with we are actually using as a complement the photometer, right? As I said, is like is the sky dome, right? So and then we try to match these two photography. So in a way, we're getting how does it look like visually and the intensity of such. Obviously, there are certain drawbacks about this, and a lot of them have been already mentioned, considering the weather aspects, but also the timing aspect, right? A photography that lasts 30 seconds, 1 minute, and a photometer that takes around 5 minutes to take. So we need to take all of this into consideration. And also, we do this description using this table matrix on the right, because challenging the part about what is light pollution, as Philippe said, is like name it, right? So here, the base that we're doing is like how many details from the landscape can I identify or can I describe, right? First of all, we need to identify if the source of light is natural, because we could be doing this in a very isolated place, and just well, it has been mentioned that the light from the stars even like can influence the whole situation. But if we know that there's artificial light close by, then we start asking the questions. Can I, for example, can I see what's in front of me? Can I see if this is a map or this is a rock? All the way to, do I have enough light to identify what kind of rock, what kind of plant is this? Can I see colors? So that's more or less in a qualitative way, we start gathering this information in order to determine like, okay, this is low, medium, or high pollutant. We can move forward. Now, for remote sensing, what we are working with currently is, so on the one hand, so low resolution information, we create some maps that show a comparable category across all our islands, right? Because like it is kind of difficult to compare an island like Tenerife, which is like highly active socioeconomically, against something like Corvo, which is a very, very small island with very, very low activity, right? So we did create a set of maps that help like have the same similar categorization or classification in order to spot certain hotspots, right? And how close or invading the Natura 2000 sites are, which is most of the focus here. The affectation we can have towards the Natura 2000 site. Now, when we go into the ocean, this is a little bit of the approach that I took. I have two sets, one for coastal. Now, coastal, I mean, from the coast to 5 kilometers in the ocean. Where can I find the same conditions as inland? So that's it, kind of like the dispersal of the light that my island is emitting. That's what I'm trying to see. And the other set, which is like more into the ocean, it's to see again, it's kind of the same patterns, like what kind of scores am I getting over here? Obviously, there are a lot of considerations, once again, because the quality of data for areas that are not in non-interest tends to be conflicting, right? For that, eventually, we aim to compare this with both with vessel activities and also with certain marine bird species of interest, right? We're trying to see where they move, how they locate up on space. Lastly, the other part is high resolution, which was with Jolene -1, which is to the equator, a 7 centimeter pixel. So that allows us to identify hotspots in the island, only in the island of Madeira, in more detail. Even like we are also trying right now to develop a way to acquire like the association between the public lighting on the streets and these hotspots that we have. As you see also on the right side of this slide, we also comparing like according to the land use, the land use maps, like where can I expect more brightness, right? And right now I do have only two classifications, two categories, sorry, but there was another category over here, which is parks and leisures, right? And here we were interested in seeing like, where can I expect more, or where has been registered more brightness. Now, to the last slide, just a little bit more of this conversation of like what is nice of what good things, cool things are from the job that we are doing, and what are the challenges that we have encountering. So from the part of the photography and brightness measurements, sure, it is something that is nice, informative, very good for communication, which is part of the interest of this project. Eventually, well, I called it pixel analysis, but I think it was shown previously in a more appropriate and formal way, which I would love to move onto that. Now, from the brightness measurements, we have a quantifiable data that if we keep collecting this information, eventually we can get something more statistically significant, right? Now, for the challenges, it's like getting to the sites, having permits, tends to be obviously challenging and sometimes even dangerous. Also, as it has been mentioned previously, like the weather part, right? Like sometimes clouds tend to be and increase the brightness, right? But sometimes it doesn't, does the absolute opposite, creates an even darker area. And aside the clouds or relief clouds, we have the humidity itself that will allow the horizontal, basically like horizontal view, right? Like we don't exactly have a way to measure like this intensity, this brightness that I am capturing, how far is it, right? I can have an estimated with the photos, but from the photometer aspect, it is a little bit harder. So yeah, so that's a little bit of a summary. There are way more things, like a lot of variables that are in control and a lot of arbitrary categories that we are also considering. That we hope that on the long run, this can create enough information to try to do something more stable. And from the remote sensing part is obviously the quantifiable part, the easy to process distribution and those aspects. But sometimes the low resolutions, especially for islands with such an aggressive topography and relief, we can lose a lot of the useful information. Therefore, having a high resolution image or data tends to be cost high. So we're trying to balance among all of these challenges. And yeah, from my side, I think that's about it.
Merci beaucoup, Fernando, pour cette présentation.
Thank you, Fernando, for your presentation. So I will invite you to switch your cameras on and start the last Q&A session. There is already one question for all three of you. Because we've seen there's many different problems in measuring this light pollution. So according to you, what is the privileged method for measuring?
Can you come again?
I don't know who wants to start. Philippe? Lorraine? Fernando? So for me, the privileged method necessarily uses modeling, and there are data that can show light pollution starting even from low resolution, allowing therefore to analyze in a very interesting way the level of light pollution wherever in the world, and especially, of course, on coastal areas. So the first thing to do is to take a look at accessible models that already provide precise information on brightness, and then The other question is a little bit more complex, and we need measurements and we need specialized tools.
Merci Philippe.
Thank you, Philippe.
Merci Fernando.
I don't know if Fernando or Lauren want to comment? Lauren?
Yeah, I would just like to say I think that the methodology also depends a lot on scale. So the modeling that Philippe's been talking about is really good at a big scale if you're interested in a wide area. We use our cameras at nesting beaches, for example, which is in the range of, I guess, tens of kilometers of an area of interest that we're after. But then you've also got a light specific scale as well. So you can look at using a spectrophotometer, for example, to measure the light coming out of each light in a facility, and knowing the intensity of that specific light bulb and the wavelength of light associated with that light bulb, and if you can see it from different places. So I don't think it's going to be a one method fixes all. It is a bit more, I guess, site and issue specific, depending on what you're interested in and what lighting challenge you need to overcome.
Okay, so to complement, I'll just piggyback from what Lauren was saying. Absolutely, scale is very important because no land is the same. While macro scale information it's always useful. We need to consider eventually, especially for decision making, right? Because for us, all of this needs to land into decision makers and changing infrastructure and that kind of stuff. So eventually we need to come down into the lower scale. But besides the scale, I think something that needs to be included or is imperative for me is a temporal aspect, mostly on the long run, like how many, like the changes we see across time. For example, especially when a lot of the times we need to use qualitative, categorical things in order to try to determine if something is light polluted, right? Just for example, of that matrix that I just showed, is it possible to keep collecting information, keep reporting of the characteristics that I have in that given area that eventually will help me to estimate if that area continues to be highly or low or medium polluted. So it's a matter of scale, temporal aspects of how we collect data.
Merci pour ces compléments. Marie, je
Thank
te
you
laisse.
for your comment. Marie, I will leave you the floor for all the other questions.
Oui, alors une question.
Yes, there is
dont Philippe a déjà répondu dans le chat, mais je pense
a question. I think Philippe answered in the chat, but I think it would be nice to have further comments and also with the translation. So what is the cost of the different methods that you have introduced?
Est-ce que vous avez entendu ma question?
Did you hear my question?
I can jump in quickly, at least from my side. Again, I think that is kind of context specific. So for in-house camera systems that different companies might have, that will obviously change the cost versus, I guess, more publicly available models or things like that. Philippe might be better placed to talk to that. But I guess from an equipment perspective, it really depends on if you're looking at something, available off the shelf versus something custom that would also require some time investment on your part as well. So I apologize, that's not the most specific of questions. It's just a challenging one to answer.
Well, as a follow-up to that,
Juste pour compléter, donc il existe, on a vu
just to complete, we have seen different systems of light pollution. The basic system is well known by astronomers, and we call it SQM. And so it starts from a few €100. Now, if you want some more automatic versions, you need about €300 to have a basic system. If you want to take photos with a sky quality camera, we are talking about €5,000 to have a calibrated tool and a software allowing you to do the analysis. So these are more available in terms of cost and public. Thank you, Fernando. Maybe you wanted to add something?
Yeah. I'm okay. To not make a comment about the actual devices or SQMs or the type of photometer. I think it is also pretty important to assess the risk and the reliability of the devices that we are getting, right? So, for example, we're using a high resolution image that we need to actually purchase for something that is not annual or semestral information. The cost is high and the risk is probably even higher because you are shooting into the sky and you don't know if you're gonna get eventually, which that actually happened. Like we lost a little bit of information probably because the cloud density on the island was so high that it was impossible to get certain areas of the island. So aside of how much a device or a service or a product costs, it's very important to assess the risk of that acquisition. For example, for Lauren, she was saying the risk of having a very nice turtle kicking the camera and saying goodbye immediately in seconds. So like we had a similar situation with birds, getting to a colony of birds and they will start saying like, what's that? And so it's when we assess cost, we need to assess the risk of losing or not acquiring reliable information. That is very important.
Merci beaucoup pour votre réponse.
Thank you
Une
for
autre
your answer. So there's another question.
principaux commanditaires dans
So
cette étude de mesure
who
de la pollution lumineuse?
are your main clients in terms of studies for measuring light pollution? I will answer very quickly. Basically, in France, natural parks, regional and national natural parks. There's also other institutional players like collectivities or large towns who are trying to create, black roads, and so other people who are involved with regulations and are interested in light pollution, but normally it's already protected area on a national and regional level.
Est-ce que c'est aussi le cas pour vous, Fernando?
Is it the same for you, Fernando?
Well, not necessarily. I wouldn't call them clients. It's for us, this project we are collaborating, it's literally partners. Now, who are those partners? Yeah, they are governmental from the municipalities, right? It's specifically from the Portuguese side, they are literally partners, right? From the Spanish, from the side of Spain, we are collaborating with another NGO similar to us, which they are not partners, the two municipalities in the Canary Islands, but they kind of are associated with the project. But for us, it's directly with the municipalities. because they are willing, they've been given also the part of the money to do pilot areas and change public illumination.
Merci beaucoup. Peut-être que Lorraine, vous avez quelque chose
Thank
à
you. Maybe Lauren wanted to add something
pour savoir
to,
Yeah, so
and I will complete the question. In terms of methods and diagnostics, are there concrete actions that have been adopted?
I guess from our side, we work with a range of clients. A large number are from the oil and gas industry and the resource sector, whether that's for existing developments or proposed new ones. But we've also worked with local governments, smaller companies, really anyone who's interested in either their current lighting situation or how to minimize impacts of future ones. And the Sky 42 cameras we use are probably our main go-to for the sort of work that we're doing. But depending on what the questions are, we have also applied different approaches. The spectrophotometer I was talking about earlier with lighting audits, where the interest is more the specific light bulbs that are already in place, is things that we've looked at in the past. So it's really varied from small to big light bulb to facility. It keeps things interesting constantly. But yeah, again, the method is often used or chosen to suit the question rather than one strategy applied across all of them.
Merci beaucoup. Et peut-être
Thank you.
une dernière question.
Maybe a last question.
Vous nous avez présenté
You have introduced
des présentations très visuelles à base de cartes, etc.
very visual presentations.
Conscience de ce
Can
problème.
you use this in an educational way to help people learn about light pollution?
Un problème connu ou
I don't know if this is a very well-known issue, a very well-known problem, or do we need to spread the awareness more?
Alors, de mon côté,
So,
les
on my side,
utilisés à des fins pas seulement
it's very important
scientifiques, soit pour des articles,
to use these analyses on an educational way, for example, with the
puisque la pédagogie
scientific articles, but also
à la fois pour convaincre
education is very important to convince
de l'importance
private
de la lumière,
and institutional players that there is a high importance in the right kind of lighting, and also to evolve regulations in this sense. In France, at the moment, they are trying to change regulations on public lighting, and this is a work that has been going on for the last 10 years, and it does use material from different associations. For example, the Association for the Protection of the Skies and the Nocturnal Environment. So it's very important to change mindset, of course.
Merci Philippe. Fernando, est-ce que vous voulez compléter?
Thank you, Philippe. Fernando, would you like to make a comment?
Yes, of course. So yes, it is important. Actually, our project Nature at Night has a lot of actions dedicated to education, sensibilization of the public. We have conducted surveys monitoring the perspective of the impression of the general public. There have been, for example, from the map side of things, like notice boards placed close to Natura 2000 sites. There have been events with the public where we talk about them, we teach them through the importance of biodiversity, taking care of the biodiversity and such. And also, even from the legislative aspect, we are trying to tackle over there certain recommendations. From the academia part, yeah, it's on the midterm future, like once we have like properly methodology of treatment of certain certain tasks, we want to go into the publication in a formal way, right? But the reality is that we are more focused directly with the public of the islands.
Merci Fernando. Et du coup, est-ce
Thank
que
you, Fernando. And
ces diagnostics permettent d'influencer les
does
autorités
this diagnosis allow to influence authorities in their way to manage the land, Lorena?
So can you just clarify that question? Sorry.
Can you
Oui, est-ce que du coup ces productions
so
cartographiques
this
peuvent influencer,
maps,
les
will they
autorités
influence
dans l'aménagement
public authorities so that they actually change their land usage
d'éclairer,
and also, of course, public lighting,
nocturne?
especially at
Yes.
night?
So I won't go too much into it because it will feature a big part of the webinar next week, I believe. But yes, we're already seeing evidence of that through increased conversations. As it's been noted, a lot of this work is very visual. We talk to everyone from our clients in industry through to high school students about this. And a big part of it is just a lack of awareness of what light can do, or artificial light. So yeah, I think the conversation is growing. And when you can show someone what a big difference it makes just thinking about lighting, there is room for change, and it's coming. But yeah, Celine, I'm not sure how much I should speak to this knowing the content of next week's webinar.
Oui, effectivement, je pense qu'il ne faut pas qu'on s'étale trop pour pas déborder.
Yes, I think we shouldn't give away too much today because this is indeed the topic of next webinar. And just one last question, and then we've done enough for today, because there are so many different methods. You know, we can't talk about everything in such a short space of time, and there's so many things that need to be built on top of one on top of the other, and you know, but the awareness is an important subject. Public awareness, private awareness. So have you got like a last takeaway for our public? Last takeaway at the end of this webinar. Lauren?
Yeah, sure. I think that our progress in monitoring artificial light is showing how valuable this work is, but the conversation alongside that work is equally as important. And it is that rapid ability to change lighting that I think is the important thing to focus on too. People just need to have that conversation, and big change can come from small actions. So yeah, it's going to be a team effort, but I think a very well-deserved one.
Merci Philippe. Je vous passe la
Thank
parole.
you, Philippe.
J'ai pas entendu le début là, mais peut-être que c'est à moi. Oui.
I maybe didn't hear the beginning of the question, but never mind.
Je pense que
Just to finish off,
beaucoup de choses à faire, pour
I think there's so much to do
l'impact de la pollution lumineuse.
to understand the impact of light pollution on biodiversity. And from this point of view,
Et la métrologie
modeling
absolument essentielle.
and methodology are essential elements that we need to develop.
Domaine complexe.
There's so many tools to use. It's such a complex area because light pollution touches the physics of the atmosphere, and the physics of the atmosphere is very complicated. So there's so much to do, a lot of work to do, but it is necessary. We must do it. Thank you. Fernando, I will leave you with a last comment.
Well, no pressure there. Well, it is fantastic that your organization is keep promoting and communicating to a broad audience and an interest audience. That it speaks a lot of the importance of this topic and where are we moving forward, right? also, if I talk locally, and especially as a foreigner in these islands, it's fascinating to me to see the interest, even from the governmental side of things, having this real willing to collaborate and do change, right? It's great, especially when besides the socioeconomic and the economic impact that this can go into the saving some coins, it's also keeping the interest on the benefit towards nature, towards biodiversity, right? And once again, seeing the local people here being engaged, interest, and liking these marine birds that you can only hear them during night, it is fascinating. And it's great that we're doing this and continue. So it is a high responsibility in all of us to actually do a good job and present very, very, very good results in this. So thank you to all y'all. And yeah, let's keep moving.
Merci à vous trois et effectivement, on sera ravis de...
Thanks, everyone. We are, in fact, very happy to continue sharing all of the recommendations and solutions in the third webinar. So thank you, Lorraine and Philippe and Fernando for your interesting contribution. Thank you, Isabella, for her translation. And we are going to see you in our next webinar, May 30th. Thanks to all of our public, all of our audience. Sorry to have to close so quickly, and see you next time. Goodbye.
Au revoir.